Hello! Welcome to the Learn English Lab. Today's podcast is 20 plus C2 level vocabulary on technology and internet.
It's great to be here. And I have to say, looking at the list of terms we've got lined up, I'm genuinely excited about this one.
Me too. Because we're not just, scratching the surface today. We aren't going to spend an hour defining mouse or keyboard.
No, absolutely not. We're aiming much, much higher.
Right. The goal today is to really bridge that gap, that space between being a casual user who, knows their way around the web and being someone who can actually command a discussion in a boardroom about IT infrastructure.
And that's such a crucial distinction.
We want to take you, our listeners, from that basic fluency right up to C2 level mastery.
Yeah, and these words, the vocabulary we've picked out for this deep dive, they aren't just buzzwords. They're not just for impressing people.
No.
These are the essential structural terms that professionals are using every single day. We're talking about software engineers, cybersecurity analysts, product designers, IT consultants.
The people who actually build and maintain all this stuff.
Exactly. These are the terms you'll find in high-stakes discussions, in technical documentation, academic papers. If you want to understand why a project is delayed, you need this vocabulary.
It's really all about precision, isn't it? It's the difference between saying something like, ugh, the internet is being weird and slow again.
Which we've all done.
We've all done it. But the difference between that and being able to say, it looks like we're experiencing a significant latency bottleneck, probably at the network layer.
That is a perfect example. One sounds like, a complaint. The other sounds like a diagnosis from a professional who actually understands the system.
It signals competence.
It really does. It completely changes how colleagues, clients, how everyone perceives you. It shows you get the underlying mechanics, not just the surface level symptoms.
So our mission for today is pretty clear. We're going to dive into over 20 of these advanced terms. We'll break down the definitions, of course, but also look at the history, which is often surprisingly interesting.
Oh, definitely.
And we'll talk about natural collocations, how to actually use these words in a sentence so you don't sound like you just, swallowed a dictionary.
Right. We're aiming for that natural, authoritative usage.
Okay, let's get into it. We have a lot of ground to cover, so we've organized this whole thing logically. We're going to start with the physical world, the hardware, and how accessibility has changed.
Sounds like a solid plan.
Then we'll move into the infrastructure, the software, the interface, and we'll finish up with security.
Let's do it, starting with hardware.
So the first term on our list is, it's a bit of a blast from the past, but it's absolutely crucial for understanding the lineage of the device that's probably in your pocket right now. The word is palm top.
Palm top. Yeah, even just saying it sort of evokes a very specific era, doesn't it? The 90s.
It really does.
By definition, a palm top is a small handheld computer that's designed to fit, pretty literally in the palm of your hand.
I feel like if you're under 30, you might never have seen one of these in the wild.
That's highly probable. I mean, today, they're acknowledged as being largely obsolete. But, and this is the key point, they are the direct ancestor to the modern smartphone.
The missing link.
You got it. You really can't understand the evolution of the iPhone or the Android ecosystem without acknowledging the palm top. These things had their moment. They peaked in the 1990s.
I have such vivid memories of seeing business people on trains back then, just hunched over these tiny little screens, trying to type on these miniature keyboards with their thumbs. It looked painful.
It was the height of productivity at the time. I mean, devices like the HP 200LX, they were considered marvels of engineering. And unlike modern phones, which are really media consumption devices first and foremost.
Right, for watching videos and scrolling.
Exactly. Palm tops were trying to be miniature desktop computers. They often ran full operating systems like MS-DOS or Windows CE. You could run actual spreadsheets, databases right there in your hand.
The thing that always gets me when I look back at the specs now is the power management. It's just mind-blowing.
It is shocking by modern standards, isn't it? Because they weren't constantly pinging cell towers or running GPS or powering these huge, bright, high-resolution screens. They had just remarkable battery life.
How remarkable are we talking?
I mean, a palm top could run for weeks on a couple of AA batteries.
Weeks? Are you serious? My phone barely makes it to dinner time if I watch a few videos on my commute.
It was just a different set of priorities. We've traded that incredible longevity for constant connectivity and, screen quality. But the vocabulary here is important. You'll hear related terms like PDA, personal digital assistant.
Yeah, I remember that one.
Or pocket PC. But palm top is the term that specifically captures that early ambition of shrinking a full laptop down to hand size.
So if I'm in a meeting talking about the history of mobile computing, the palm top is the key origin point.
It's the bridge. It's the bridge between the room-sized mainframes of the past and the pocket-sized supercomputers of today.
Okay, great start. Now let's move from the computer itself to all the little things we attach to it. This next word is one that always makes people chuckle a bit, but it is absolutely everywhere. Dongle.
It is a rather unfortunate sounding word, I'll give you that. But functionally, it's become indispensable. A dongle is simply a small piece of hardware that connects to a computer, or a smartphone, or a TV to provide some kind of additional functionality.
I feel like we're living in the age of the dongle right now, especially with these new laptops getting thinner and thinner and losing all their ports. I need a dongle for everything.
That is the modern consumer frustration for sure. You need a dongle just to plug in a standard USB drive or an HDMI cable to a projector, but historically, the term actually has a more serious usage, especially in the enterprise world.
How so?
Originally, dongles were most often used for software licensing.
Oh, right, like a physical key to unlock the software.
Precisamente. You might hear the collocation security dongle. If you bought very expensive professional software, think high-end CAD tools for architecture, or specialized music production suites, the software would not launch unless its proprietary dongle was plugged into the machine.
Wow, so it was a form of physical copy protection.
A very effective one.
So if you lost the dongle, you just lost access to your $5,000 piece of software.
A terrifying prospect for any working professional, believe me. But today, the usage has broadened out so much, we see HDMI dongles everywhere, like the Chromecast or the Fire TV stick.
Right. Those are devices that you plug into a quote-unquote dumb TV to give it smart capabilities.
You've hit on the key distinction. It's about modularity. You're essentially adding a brain to a screen that doesn't have one.
It lets you upgrade the functionality without having to replace the whole expensive TV.
Yes. You just swap out the $20 dongle for the new model. It's incredibly efficient.
Now, speaking of plugging things in, our next term is a concept we completely take for granted today, but it was a massive, massive marketing revolution when it first appeared. Plug and play.
Oh, this is a great one. It functions as both a noun and an adjective, and it refers to technology that allows a device to be used immediately upon connection to a computer without needing any kind of extensive installation or manual setup.
I absolutely remembered the dark ages before this. You'd buy a new printer, bring it home, you're all excited, you plug it in, and just nothing happens.
Or worse than nothing, you'd get these cryptic error messages. You'd have to find a floppy disk or a CD-ROM, install something called a driver, restart the whole computer, and then deal with interrupt conflicts.
Interrupt conflicts. That is a phrase I am very happy to leave in the past.
Me too. It was a nightmare for the average user. So Plug and Play, or PNP, originated with Microsoft's specifications in the mid-90s. The whole idea was that the hardware and the software should be smart enough to basically introduce themselves to each other automatically.
And now it's just the baseline expectation for everything.
It is. I mean, if you plug in a new mouse or a webcam today and it doesn't work instantly, your first thought is that it must be broken.
Yeah, you don't think, oh, I need to install the driver.
No one thinks that anymore. The collocation we often use now to describe a seamless installation is a true plug-and-play experience. If you're writing a product review or a report, that phrase signals high quality and exceptional ease of use.
And the opposite, the antonym, would be something like requires manual driver installation.
Which, in this day and age, is essentially a sign of design failure, unless you're working with some very specialized high-end industrial equipment.
Let's shift gears a little bit to accessibility and the interface between us, the humans, and the machine. This next technology has, well, it's gone from sounding like a robot with a head cold to sounding nearly indistinguishable from a real person. I'm talking about text-to-speech, or TTS.
TTS is such a fascinating field because it sits at the intersection of linguistics, audio engineering, and, more recently, artificial intelligence. The technical definition is the conversion of written text into spoken voice output.
We all used to joke about how bad it was, that really robotic, choppy sound.
That was the old method, what was called concatenative synthesis. It was basically just gluing together little tiny snippets of recorded human sounds. It had no flow. It completely lacked prosody.
Prosody. That's a new one for me. What's that?
Prosody refers to the rhythm, the stress, and the intonation of speech. It's all the non-word stuff. It's how you know just from my tone of voice that I'm asking a question
Okay.
or being sarcastic. Old TTS systems were completely monotone. They had zero prosody.
So what changed? What was the big leap forward?
In a word, deep learning and neural networks. Modern TTS engines, like the ones from Google or Amazon, they don't just read words one by one. They analyze the whole sentence. They understand the context. They can predict how a sentence should flow naturally.
So they can offer what you might call near human prosody.
That is the perfect phrase for it. And while many of us use it for convenience, asking a smart speaker for the weather, its real importance is in accessibility.
Right, for users with visual impairments.
It's absolutely critical.
Mm-hmm.
For them, TTS is how they navigate the digital world. Screen readers use TTS to turn the visual web into an audio experience. It's also huge in e-learning and navigation apps.
Of course, when my car tells me to turn left in 200 meters, that's TTS in action.
That's right. And you'll also hear collocations like synthetic speech or voice synthesis, but text-to-speech is really the industry standard term.
Okay, that wraps up our first section on hardware and accessibility. We've gone from the nostalgia of palm tops to the modern utility of dongles, the seamless ease of plug and play, and the incredible sophistication of TTS. Now let's go a layer deeper.
Let's talk about the invisible pipes that make all of this stuff work.
Exactly. Section 2, the infrastructure of the internet.
This is where we move from the device that's sitting in your hand to how that device actually communicates with the rest of the world.
And first up is an acronym that is probably stapled to the wall of every office IT closet in the world, LAN.
LAN, Local Area Network. The definition is really right there in the name. It's a network that connects computers within a limited physical area, like a single residence, a school, or an office building.
So is my Wi-Fi network at home technically a LAN?
It is, yes. But usually when we talk about LANs in a professional context, we're referring to the larger business infrastructure. The LAN is what allows all the employees in an office to share printers, to access central file servers, and to communicate internally without sending all that data out over the public internet.
And it's distinct from the WAN, right? WAN.
Correct. The WAN is the wide area network, which is, for all intents and purposes, the internet itself, everything outside your building. The LAN is your own private high-speed bubble.
What kind of technologies are we talking about inside that bubble?
Well, you'll hear about Ethernet. Those are the physical cables, usually blue, that run through the walls and ceilings. You'll hear about Wi-Fi standards like 802.11ax, which is also called Wi-Fi 6. And in more complex setups, you might hear about VLANs, virtual LANs, which are a clever way to segment the network for security.
What does that mean, to segment it?
It means you can create separate virtual networks on the same physical hardware. So you can keep the finance department's sensitive data completely separate from the public guest Wi-Fi, even though they're using the same routers and switches.
Got it. Okay, now within that network, some computers are just users, but others are. Well, they're in charge. And that brings us to our next term, host.
Host is a very versatile word, but in networking, it has a very specific meaning. A host is a computer or any other device on a network that provides services, resources, or data to other computers, which we call clients.
So it's kind of like a host at a dinner party, providing the food and drinks to the guests.
That analogy holds up surprisingly well. A file server is a host because it holds the files and serves them to you when you request them. A web server is a web host because it stores all the website data and sends it to your browser, the client.
We also hear the term hostname quite a bit in IT.
Yes, and that's simply the human-readable label assigned to a device on a network. It's much, much easier for people to remember to connect to marketing server 001 than it is to remember to connect to, say, 192.168.1 Pod 1.
Definitely. Now, when we talk about networks, everyone is obsessed with one thing, speed. But speed is actually a pretty vague, unhelpful term. We need to break it down into two very different, very important concepts, bandwidth and latency.
This is perhaps the single most important distinction for anyone trying to troubleshoot a slow internet connection. Let's start with bandwidth. Bandwidth is the maximum rate of data transfer across a given path.
The classic analogy here is the water pipe, isn't it?
It's a classic because it works so well. Bandwidth is the width of the pipe. If you have a really wide pipe, you can push a huge volume of water or data through it every second.
So streaming a 4K movie on Netflix, that requires a lot of water.
Exactly. We would say it consumes enormous bandwidth. If you have a gigabit fiber connection, you have a massive pipe, so you can download huge files in seconds, and multiple people can stream 4K at the same time.
Okay, that makes sense. But having a wide pipe doesn't mean the water gets from the source to your house instantly.
And that right there is latency. Latency is the time delay. It's the time it takes for a single packet of data to travel from the source to the destination. To stick with the analogy, bandwidth is how wide the pipe is. Latency is how fast the water actually flows from point A to point B.
So you could have a gigantic pipe, huge bandwidth, but if the water is moving really, really slowly, you have high latency.
Correct, and high latency is the absolute enemy of any real-time interaction.
This is why online gamers are always screaming at their screens about lag.
Yes, that's a latency problem. In competitive gaming or in high-frequency financial trading, you need low latency. You need the data to arrive in milliseconds. Engineers spend their entire careers trying to optimize systems to reduce latency.
So let me see if I've got this. If I'm on a video call and the picture is perfectly crystal clear, that's good bandwidth. But we keep accidentally interrupting each other because there's a noticeable delay between when I speak and when you hear me.
That is a classic latency issue. You've got a wide pipe, but it's a very, very long pipe. The data is taking too long to travel.
Got it. Now, to test that connection, we have a verb that has jumped straight from the IT command line to the corporate water cooler. To ping.
This is a wonderful example of tech slang entering the general business lexicon. Technically, to ping a computer means to send it a tiny signal. It's actually an ICMP echo request packet, and then you wait for it to send a reply.
It comes from sonar, doesn't it? Like on a submarine.
It does. A submarine sends out a ping sound wave. If that wave hits another object, the sound bounces back, and they know something's out there. In IT, you ping the server to see if it's online and responsive. If it replies, you know the connection is alive.
But I hear this every single day in the office in a completely different context. Hey, I'll ping you on Slack later.
Yes, it's made the jump. In informal business English, to ping someone now just means to send them a quick short message, usually on an instant messaging platform like Slack or Microsoft Teams.
It feels different than saying, I'll email you. It's less formal.
It is. I'll email you implies a more formal, perhaps lengthy communication that doesn't require an immediate response. I'll ping you implies immediacy, low friction, and brevity. It's like a gentle digital tap on the shoulder.
Ping me when you're free. I'll probably say that 5 times a day.
Okay, that covers the infrastructure. We understand the LAN, the host, and the critical difference between bandwidth and latency. Now let's talk about the software that actually runs on top of all this. Section 3, software architecture and development. Right. This is where we look at how developers actually build the systems and applications that we use every day.
And there's probably no bigger divide in the development world than the one between front end and back end. Let's compare and contrast these two.
This is the fundamental duality of almost all modern web development. The front end is the part of the application that the user sees and interacts with directly. It's the user interface, UI, and the user experience, UX.
So it's the buttons, the colors, the fonts, the layout on the web page.
All of that, everything you see in your browser.
Yeah.
Front-end developers use languages like HTML for structure, CSS for style, and JavaScript for interactivity. They use big frameworks like React or Vue. Their main focus is on making the application look good, feel responsive, and work well across all different screen sizes, from a tiny phone to a huge monitor.
Okay, so that's the shiny surface. What's the back end?
The back end is everything you don't see. It's all the machinery under the hood. It consists of the server, the database, and what's called the business logic.
Business logic, what does that mean?
That refers to the set of rules that determine how data is created, stored, and changed. So, for example, if you try to log into your online bank account, the front end is the part that gives you the nice-looking login form where you can type your password.
Right.
But the back end is the part that takes that password, securely checks it against the database, verifies who you are, and then makes the decision about whether you're allowed in or not.
So if the front end is the dining room of a restaurant, you know, the nice decor, the menus, the friendly waiters, then the back end is the kitchen.
That is the standard analogy, and it's perfect. You, the customer, never see the kitchen. You don't see the chefs or the supply pantry or the dishwashers. But if that kitchen isn't working properly, you are not getting any food.
No matter how nice the dining room looks.
Exactly. Back-end tasks involve things like optimizing database queries so they run fast, managing system backups, and constantly monitoring the health of the servers.
And connecting these two worlds, the front end and the back end, or connecting different applications to each other. We have the API.
Application Programming Interface. If you only remember one acronym from this entire deep dive today, please make it API. It is the absolute connective tissue of the modern internet.
Okay, so what is the core definition? What is it doing?
An API is a set of protocols, rules, and tools that allows different software applications to communicate with each other. It essentially defines a contract for how different software components should interact.
Why is this so critical for business? Why does everyone talk about APIs?
Because it allows companies to leverage each other's technology without having to rebuild everything from scratch. Think about a company like Uber. They didn't build their own global mapping system. That would have cost billions. They used the Google Maps API.
Yeah, so they just plugged into Google's existing map service.
That's it. They didn't build their own payment processing system from the ground up either. They almost certainly used an API from a company like Stripe. The API acts as a messenger. Your app sends a request to the API saying, please process this credit card payment for $20, and the API comes back a second later and says, done, payment successful.
So you're building with these pre-made powerful blocks of functionality.
You are. And you'll hear collocations around this like RESTful API, which is a specific design style, or API endpoint, which is the specific address you send your request to, or an API gateway, which manages a whole collection of APIs.
This seems to lead perfectly into our next term, which is interoperability.
Interoperability is the ultimate goal of having good APIs. It's the ability of different systems, devices, or software applications to seamlessly communicate and work together without any special effort from the user.
Seamlessly, that's the key word. So where is this most important? What's a real-world example?
Healthcare is a massive one. Imagine you have a big hospital using one software system for its patient records and a small specialist clinic down the street using a completely different system. If those two systems lack interoperability, your medical records are stuck in a digital silo. They can't share data electronically.
So you end up having to get someone to print out the papers and physically fax them over.
Which is incredibly inefficient, costly, and frankly dangerous in a medical situation. Industry standards like HL7 or FHIR in healthcare are all about solving this interoperability problem. It's also critical in the Internet of Things, or IoT, getting your smart light bulb from one brand to talk to your smart speaker from another brand.
Seamlessly communicate. I really like that collocation. It implies absolutely zero friction for the user.
That is the dream state of all modern technology.
Now here's a term with a very weird, very cool origin story. Bootstrap.
This is a term with a few different layers of meaning. The etymology, the origin, comes from the old phrase, to pull oneself up by one's bootstraps.
Right, which is physically impossible to do.
It is. You can't stand in a bucket and lift yourself up by the handle. The phrase implies starting a process without any external help. In computing, booting a computer is short for bootstrapping. It refers to the tiny, simple program that runs the instant you turn on the power. Its only job is to initialize the hardware and then load the much larger, more complex operating system. The computer has to pull itself up from a dead state.
But we also hear this all the time in the business world, right? We're bootstrapping this startup.
Yes, and it means the exact same thing, metaphorically. In that context, it means the founders are starting the company using only their own money and resources rather than taking on external investment from venture capital funds. They're building it themselves from nothing.
Okay, and just to add one more layer of potential confusion, there's also a Bootstrap framework for web design.
There is. It's a very popular library of pre-made CSS and JavaScript tools. So context is absolutely key with this word. If a developer says, I use Bootstrap on the front end, they mean the design tool. If an entrepreneur says, I bootstrapped the company for the first 2 years, they mean they were self-funded.
Got it. Next up, algorithm. This is a word that gets thrown around in the news constantly and usually with a kind of menacing, scary tone.
It really has become a bit of a buzzword for mysterious computer magic that controls our lives. But at its core, an algorithm is simply a set of rules or instructions for decision-making or problem-solving. It's a process.
It's like a recipe for a cake.
That's the best simple analogy. A recipe is a perfect algorithm. Step 1, mix flour and sugar. Step 2, add eggs. Step 3, if the mixture is too dry, then add a tablespoon of milk. If it's too wet, then add a tablespoon of flour. That's an algorithm.
But in the tech world, we usually mean something a little more complex than baking.
We do. We're usually referring to things like recommendation engines or machine learning algorithms. These are complex mathematical models that analyze huge amounts of data to make predictions or decisions. When an online store suggests a product to you because you bought something similar last month, that is an algorithm at work.
That classic, because you watched this movie, you might also like this one.
That is the recommendation algorithm. A term you'll hear in more critical discussions is the black box algorithm, which refers to a system that is so complex that even its own creators don't fully understand how it arrived at a specific decision.
And that can be a problem.
It can lead to major concerns about algorithmic bias, where the algorithm's rules might inadvertently and unfairly favor one group of people over another.
That sounds like a topic for a whole other deep dive. Okay, finally for this section, a verb that makes you sound very capable and professional. To configure.
To configure means to set up a system or a piece of software to achieve a desired functionality. It's a bit more specific and professional than just saying set up or install.
What's the nuance there? Why is it more professional?
Configure implies choice and customization. It implies that you are actively adjusting settings, selecting options, and tailoring the system to your specific needs. You don't just install a new firewall, you configure the security rules, you have to configure your new email client with the correct server details for it to work.
And you might see related terms like pre-configured, meaning it's already set up for you, or auto-configure.
Correct. Using the verb configure implies a professional standard of deliberate customization.
Fantastic. We are now moving into our fourth section, user interface and future tech. We're looking at how we actually interact with all these machines and where the technology might be going next.
A very visual and forward-looking section.
Let's start with a very simple, very common UI element that we all use every single day, the toggle button.
A toggle button is, quite simply, a switch used in user interfaces to turn a particular setting either on or off. The best analogy is a physical light switch on your wall. It has two states, on or off.
It seems so basic. Why is this on a C2 level vocabulary list?
Because precision in language matters, especially in a professional setting. You don't want to be the person in a design meeting saying, that little clicky thingy that slides over and turns green.
Fair point.
You want to say the toggle button or the toggle switch. And major design standards are very strict about how these are implemented.
How so?
Guidelines like Google's material design or Apple's human interface guidelines emphasize that toggles must provide clear, instant visual feedback. The user must know, without any doubt, if the state is active or inactive. It's a binary choice.
Like when you're filtering your email inbox, you hit a switch to toggle unread only to on.
Precisely. It's a precise term for a precise action.
Now let's look at something a lot more futuristic. Augmented reality, or AR.
AR is technology that overlays computer-generated information, images, sounds, text onto your view of the real world.
And it's important that we distinguish this clearly from virtual reality, or VR.
Yes, that's a key distinction. VR is fully immersive. You put on a headset, and the real world completely disappears. You are transported inside the digital world. AR, on the other hand, adds to the real world. You look through your phone screen or a pair of special glasses, and you still see your living room, but there might be a digital dinosaur walking on your coffee table.
The big cultural moment for AR was probably the game Pokemon Go, where people were catching virtual monsters out in the real park. But what about serious business applications?
Retail's a huge one. Apps like IKEA Place let you use your phone's camera to visualize exactly how a new sofa would look in your actual living room at the correct scale before you buy it.
That's incredibly useful.
It is. Or think of a mechanic who can wear AR glasses that highlight the specific part of a complex engine they need to repair, with instructions floating right next to it. You'll hear collocations like marker-based AR, which uses a specific image to trigger the experience, or location-based AR, like Pokemon Go.
It's blurring the line between the physical and the digital. And finally, for this section, the verb to automate.
To automate is to make a process or a system operate automatically, with the goal of reducing or completely eliminating manual human intervention.
This is the dream, isn't it? Automate all the boring stuff.
That is the ultimate goal. In the home, we're seeing this with smart thermostats that automate our heating and cooling schedules. In the business world, the really big trend right now is RPA, which stands for Robotic Process Automation.
And just to be clear, these aren't physical walking around the office robots.
No, not at all. They are software bots. They are computer programs that are trained to do the repetitive, mind-numbing digital tasks that humans hate doing. Things like clicking, typing, copying data from a spreadsheet, and pasting it into another system over and over again.
So the key collocation here would be to automate repetitive tasks.
Yes. The idea is to move human workers away from that kind of low-value work and onto higher-value, more creative problem-solving, ideally.
We are now entering our final content section, and it's a critically important one. Section 5, Security and Education.
You really can't have a serious discussion about technology today without discussing security. It is the absolute foundation of trust in the digital world.
And the bedrock of that security is a concept called encryption.
Encryption is the process of converting readable data, which we call plain text, into a coded, unreadable form, which we call ciphertext. The goal is to prevent any unauthorized access to that information. It's essentially scrambling a message using a complex mathematical formula.
And you need a secret key to unscramble it.
Correct. Without the key, the ciphertext is just meaningless noise. It's gibberish.
We hear a lot about end-to-end encryption, especially with messaging apps like WhatsApp or Signal. What does that mean specifically?
That is the gold standard for personal privacy. End-to-end encryption means the message is encrypted on my device, it stays encrypted as it travels across the internet and through the company's servers, and it is only decrypted when it reaches your device.
So not even the company that runs the app can read the message.
They cannot. They just see the scrambled ciphertext passing through. They don't have the keys. This is crucial for securing things like financial information during online transactions or private conversations.
What about the future of this? I keep hearing whispers about quantum-resistant encryption. It sounds like something out of science fiction.
It does, but it's a very real and urgent field of research. The concern is that future quantum computers will be so powerful that they'll be able to break our current encryption methods, like RSA and ECC. So cryptographers are in a race to build new, much harder codes that even a powerful quantum computer won't be able to crack.
It's a never-ending arms race. Now, speaking of threats, let's talk about the Trojan horse.
This is a classic term, of course, drawn straight from Greek mythology. In the story, the Greeks hid their soldiers inside a giant wooden horse, which the Trojans then brought inside their city walls as a gift.
Big mistake.
A fatal mistake. In technology, a Trojan horse is a type of malware, a harmful program that pretends to be legitimate, useful software in order to trick a user into installing it, and thereby gaining unauthorized access to their system.
So it might disguise itself as a software update or a free game or a cool-looking screensaver.
Exactly. The user is deceived into willingly installing it. They think, oh, I need to update my Flash player. They click install, and in that moment, they have personally invited the enemy inside their digital gates.
And once it's in, what can it do?
Almost anything the attacker wants. The most dangerous variant is called the Remote Access Trojan, or a RA. This gives the attacker full remote control of your computer from anywhere in the world. They can see your screen in real time, turn on your webcam and microphone, steal your files, and log all your passwords.
That's terrifying. Now, who are the people doing this? We usually just use the word hacker, but our research suggests there's a more specific, more accurate term we should know: cracker.
This is a nuance that is very important within the cybersecurity community, even if the general public and the media often ignore it. A hacker, traditionally, is someone who enjoys exploring the details of programmable systems and stretching their capabilities. They want to understand how things work at a deep level.
So a hacker isn't necessarily a bad guy.
Not at all. We have white hat hackers or ethical hackers who are hired by companies to break into their own systems specifically to find security bugs so they can be fixed before the criminals find them. They are the good guys.
Blood cracker.
A cracker is an individual who engages in that same unauthorized access, but with malicious intent. They're the ones breaking into systems to steal credit card numbers, to hold data for ransom, or to cause damage.
So cracker implies criminal intent.
It does. If you want to be precise and show you understand the culture, use cracker for the criminals and hacker for the skilled experts, who may be good or bad.
That's a great distinction to make. We're ending today on a slightly more positive and constructive note. Education. The term is courseware.
Courseware refers to educational software and any associated online materials that are designed for teaching specific skills or subjects.
It seems a bit academic, a bit formal.
It often is.
Yeah.
But it represents the huge shift from physical textbooks to integrated digital learning ecosystems. Courseware isn't just a PDF of a book that you read on a screen.
It's interactive, right?
Yes, that's the key. Modern courseware includes things like interactive simulations, automated grading systems for quizzes, and even adaptive learning paths. So if the software sees you're struggling with a particular concept, it can automatically give you more practice problems on that specific topic.
So the platforms that universities use, like Canvas or Blackboard, what's inside them, that's all courseware.
That's all courseware. It's the software infrastructure that underpins a huge amount of modern education.
Wow, we did it. We made it through the whole list. That was extensive.
It really was. But think about the journey we just took. We covered the full spectrum of technology. We started with the physical hardware in your hand, the palm tops and dongles.
Right. Then we went into the invisible infrastructure lands, bandwidth, latency.
Then we looked at how software is actually built, with front ends, back ends, and APIs. We looked at the interface with toggle buttons and augmented reality.
And we finished with the critical concepts of security and education with encryption and identifying crackers.
It's the whole stack, from the physical wire to the final application.
My brain genuinely feels upgraded. I feel like I could walk into a meeting with our IT department tomorrow and actually follow what they're arguing about.
And that is the entire goal. When you can correctly use terms like interoperability or latency or configure in a sentence, you aren't just communicating facts. You're communicating that you understand the entire ecosystem. You sound fluent and authoritative.
So to our listeners, here's your challenge. Pick 3 of these words we discussed today. Maybe configure, bootstrap, and bandwidth. And try to use them in a real conversation this week. See how it feels.
And really pay attention to the collocations we mentioned. Don't just say plug and play. Try to say it offers a true plug and play experience. Don't just say encryption. Say end-to-end encryption is essential. That is where the C2 level of fluency really shines through.
Absolutely. This has been a massive deep dive, and we sincerely hope you feel more confident in your technology vocabulary.
It's been a real pleasure exploring all these nuances with you today.
Before we sign off, we just have one final request. If you found this useful, if you feel even a little bit smarter right now, please like, share, and subscribe to this YouTube channel.
It really does help us keep the lights on and, well, keep the bandwidth flowing.
It certainly does. Thanks for listening, and we'll see you in the next deep dive.